All right, moving right along, we got number 4 here. It says the common ratio of a geometric sequence is 0.6. So right away, we know that the R value is in that accepted range if this is infinite. The sum of the series is 40. Now, when they just say the sum of the series, they don't say the sum of the first 5 terms or the sum of the first 10 terms. The general sum of the series, that leads me to believe that this is infinite. They want to know the first term and then list the first 5 terms of the series. So we're going to use the infinite formula, u1 over 1 minus r. This is applicable when it's geometric. R is in the right range. The sum is 40. Goes on forever, but does have a sum, because if r is a decimal, if r is 0.6, that number you would be adding every time is going to get smaller and smaller and smaller. Okay, so eventually it doesn't have an effect when it goes to infinity. So on the bottom we have 1 minus 0.6. So basically we have 40 equals u1 over 0.4. Multiplying both sides by 0.4 should give you 16 as the first term in your series. They then say list the first 5 terms. The first term times that common ratio. Next term would be 9.6 times 0.6 is 5.76, 3.456, and then 2.0736. Those are the first 5 terms of that series. Even if you add these 5 numbers up, you'll see that it's starting to approach 40, but never cross. So if you kept following that pattern, times 0.6, times 0.6, times 0.6, and then added all those numbers up for all eternity, they would never go over the limit of 40. Next, we have considering the series, the sequence 100, 95, 90.25. Find the 7th term. All right, so you could figure out R by taking this divided by that, this divided by that. R comes out to be 0.95. You could then just type into your calculator 100 times 0.95 times 0.95 times 0.95 and keep going with that until you get to the 7th term. Or you could sort of, use one of those formulas we've learned throughout the year, u1 times r to the n minus 1. This is the explicit formula when we're given u1, when we know our r value, we know how many terms we want. 7, the exponent is n minus 1. This is how we can calculate u7. This is the explicit geometric formula. That'll find the 7th term. Okay? When you calculate that out, it should come out to be u7, 73.509. All right, so that is the 7th term. Now that differs from B. This is the 7th term. Boom, right there. S7 is the sum of the first 7 terms. So this is a partial sum. It's a finite geometric. And we're going to use our u1 over 1 minus r with more stuff. 1 minus r to the n. Okay, I got the first term, 100. Got the common ratio, 0.95. Finding the sum of 7 terms, not g, but 7 terms. And then on the bottom, you have 1 minus 0.95. Make sure you're using your parentheses correctly. The sum of those first 7 terms is going to be 603.325. Next, find the sum of the entire series. In my mind, that's meaning the entire series with a dot, dot, dot. Not only out to the 7th term, but the infinite number of terms. So we're going to use that infinite formula with u1 on top and 1 minus r on the bottom. If you add all the numbers up in this pattern all the way out to infinity, you get 2,000 as your ultimate sum, or your limit. In 6, why can we find the sum of an infinite convergent geometric? Because the number that you're adding is getting smaller and smaller every time. We talked about the number of games played in the NCAA tournament. If you continued this pattern on and on forever, if you added 1/2, then 1/4, then 1/8, the number that you're adding is getting so tiny that over time, over all of eternity, it loses its effect on making this sum get bigger. It's just not getting bigger anymore because that number is negligible. Why can't we find the sum of a non-convergent? Well, that would mean that r is a number outside of that range from 1 to -1. If you're adding this in reverse, 1 plus 2 plus 4 plus 8 plus 16 plus blah, 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 that number is just going to get so huge that when you add it, you're basically adding infinity on top of infinity, which really has no logical sum. Hopefully you get it, got it. If not, we'll talk about it more tomorrow in class.